Hey guys, so here's my first little video or spiel on some of these math problems you guys have been communicating with me about. One of these problems was specifically brought to my attention by one of the students who personally messaged me, so I decided to kind of start off here. According to the student, this is on page 113 in your ADN manual. In my book, it's on page 154, but the question is number 20. It says you are to add 10 grams of drug X to 1,000 milliliters of D5W. You have a 10 milliliter vial of 50% solutions of drug X. Okay, how many milliliters will you have? So on the board here, I kind of already prepped the question. So the order calls for 10 grams of 1,000 milliliters of drug X. Okay. Currently on hand, we have a 10 milliliter vial, and here's my little vial here. It has 10 milliliters in it, and it has 50%. Now remember, when you go back to your little cheat sheet of things here, it says that 50%, you can see here, represents 50 grams per 100 milliliters. So that's how you need to kind of visualize that. When you see that percentage, that just means that there's 50 grams per 100 milliliters in that vial, okay? So we have a 10 milliliter vial that has the concentration of the drug of 50 grams per 100 milliliters. Here we have our IV bag, okay, and it has 1,000 milliliters like the order calls, and we're supposed to add 10 grams of a medication to that bag. It's supposed to be inserted in there. Now we won't personally do those kind of things. The pharmacy should be doing that. That's kind of like how current times are going. Maybe back in the day we used to do it on our own or something, but for the most part, I've never had to add anything into it. Pharmacy does that, or maybe you have to pop the bottle and shake it up or whatever, but it's all kind of attached and in there, okay? So how we want to work out this problem is we want milliliters. It says how many milliliters will you add to this bag from this concentration we have here on hand, okay? So how we're kind of going to set up this equation is what do we want to start out with on top? We always want to start out with what we want. So we always want to start out with milliliters on top, correct? And I always start out with what we have on hand. So at the moment I have 100 milliliters with these 50 grams, okay? Now we need the grams canceled out. So where else in the equation do we have grams? We have grams in our order, right? We have 10 grams ordered to be added into this. So I'm just going to add my 10 grams, and we'll just do this per dose, or however. I usually just leave it blank, but you can do per dose, per patient, per day, whatever it requires or doesn't require, and however you need to fill in the blank here so you're not messing up your equation. Okay, so now we can cross out our grams. Okay, and if we pull out our calculators or do this in our heads, 100 times 10 is 1,000 over 50, okay? So we cross out our zeros there. 5 goes into 100 20 times. And that's how we get our 20 milliliters that we will be adding into our bag. So again, just think about the problem. I always like to write my problems out like this so it's nice and organized. I always start with what my order is, what it calls for, what I currently have on hand, and what do they want? Do they want milligrams? Do they want grams? Do they want milliliters? Do they want liters? So on and so forth. Okay? Really simple. So there's your first question. Hope that kind of helps a little bit.